Good day, everyone. I am Midshipman Bayani, Angel Jim D from BSMRE 2.1 Alpha. And today, I will be talking about vapor pressure and flow regime and explaining how vapor pressure and flow regime affects PID control of a pressure measurement and control system. So let's start. So first of all, what is vapor pressure? Vapor pressure is the force exerted by a gas when it is a balance with its liquid or solid form inside a closed space. It shows how fast a substance turns into gas. When a liquid gets hot, its vapor pressure goes up. Boiling happens when this pressure matches the air pressure around it. So next is what is flow regime? A flow regime is a specific pattern or behavior that a fluid, liquid, or gas shows as it moves through a space like a pipe, channel, or a river. It is decided by speed, weight, thickness, and shape. So, vapor pressure. Vapor pressure is a pressure produced by a vapor, gas, above a liquid when the liquid and vapor are equilibrium at a certain temperature. So, higher temperature equals higher vapor pressure, and lower temperature equals lower vapor pressure. A liquid with high vapor pressure evaporates more easily. And simple example, gasoline has a relatively high vapor pressure, so it evaporates more easily than water. And next is flow regime. A flow regime describes the way a fluid, liquid, or gas moves through a pipe or a channel. The main types are, first of all, laminar flow. Fluid moves smoothly in a parallel layers with a little mixing. And transitional flow, flow changes between laminar and turbulent. And turbulent flow, fluid moves irregularly with mixing and swirling. Flow regime is commonly determined using the Reynolds number or RE. RE 2000 is usually laminar, RE 2000 to 4000 is transitional, RE 4000 is usually turbulent. So as seen here in this picture, 10 to 1000 is usually laminar flow, and in between 1 to 10,000 is the transitional, and 10,000 to 1 million is usually turbulent flow. And simple example are water flowing slowly through a pipe, it is usually laminar. When the water is flowing very fast, it is usually turbulent. So that is all. And then effects of vapor pressure and flow regime on PID control. Vapor pressure affects the pressure of a fluid, especially when the temperature changes. When a vapor pressure is high, the fluid can evaporate more easily, causing the changes in the system pressure. This may make the PID controller respond more frequently and can lead to oscillation or unstable pressure control if it's not properly tuned. Flow regime describes how the fluid moves through the piping. Laminar flow is a smooth and predictable, making the pressure easier to control. Turbulent flow is irregular and can cause pressure fluctuations and measurement noise, which may cause the PID controller to react unnecessarily. Therefore, both vapor pressure and flow regime must be considered when tuning a PID controller. Proper PID tuning helps maintain stable pressure, reduces fluctuations, and keep the control valve operating efficiently. So that is all. Thank you.